All right, kids, we are on to ellipses now. So if you remember, you watched a video, right, about ellipses. So I'm going to kind of go through the definition of an ellipse, okay, and then talk about some of its characteristics, just like we did with a parabola, what you need to find in order to graph it without a calculator. I'm on worksheet 7-4, okay, and we are covering 11.3 in the textbook, all right? So an ellipse is all the points, a set of points, where the sum of the distances from two fixed points, which are your foci, right, is constant. So if you remember that weird video that you watched when I introduced the different conic sections, he took a string and he created an ellipse, okay? And the length of the string was always the same regardless of where he was. So like if his pencil, I believe, was here, the string was exactly this long, okay? And the combination of those two lengths or distances, distance 1 and distance 2, right, would always be the same and constant, okay? But it's always from the foci, all right? So those are the points that create the ellipse, but when you're actually going to graph them, what you're going to be doing is graphing these 1, 2, 3, 4, 5 points, okay, on a coordinate grid, all right? So similar to a circle, okay, we're going to have a center, all right, and you're going to see it's going to be in HK form, all right? We're going to have it in standard form, so you'll be able to see those. Then you can see there are going to be two vertices, okay, that are always on the longer part, okay, or the major axes of the ellipse, all right? And those are the two endpoints of that major axes. And then you're going to have a shorter distance here, where these are what we're going to call them is the co-vertices, okay? So these are the points you're going to have to name, just like you did with the vertex and the points on the lattice rectum. So these are the points you're going to find, okay, and tell me the coordinate pairs of. And this is called our minor axes, right? Minor being the shorter one, all right? You don't have to graph the axes, but I will use those words, all right? And an important point here is the foci, right? And I usually use X's, okay, because they aren't actually on the ellipse itself, but they help determine the shape of the ellipse. Those are always on, so your foci are always on the major axes. Okay, just like when you had a parabola, the foci was always inside the parabola. Okay, the foci here are going to be on the major axes, okay? So some big things that we're going to talk about, I'm going to come back to this sheet here. Some key things that you're going to have to remember for an ellipse, all right? So I'm going to swing back to this after we talk about what the equation looks like. All right, so let's go to our second page here. So standard form, okay? If you look down here, these are the simplistic standard forms, okay, you can see the x squared and the y squared, all right? So unlike with a parabola where there's only one squared variable, now there's going to be two squared variables, like there is a circle, okay? But now when you write it in standard form, there's going to be an a squared and a b squared. There's going to be denominators, all right? And we'll take a look at graphing one in just a minute. But if you take a look here, these two equations change ever so slightly. There's always addition for an ellipse between your x squared and your y squared, all right? And then do you see how we switch the a squared and the b squared here, okay? Wherever the a squared is, that creates the major axes. If I could write, that would be great, okay? So that's going to be our major axes. So the major axis is going to be horizontal in the x direction, okay? Because that's where the a squared is, and I'll talk more about what the a squared is, all right? Then if you look here, the a squared is underneath the y. So therefore, that's going to create our major axes, okay? And our major axes are going to be in the y direction, okay? So if an a squared, right, is underneath the y squared, you're going to have a longer ellipse, okay? If you have the a squared underneath here, you're going to have a, like, fatter ellipse, if you will. I'm not sure how you want to talk about that. But A is always going to be, and let me come back to this, okay? A is always going to be your distance from the center to your vertex. So notice that's to the for the major axes. So when I go to graph this like you would with a circle, right? You're going to go A direction to the left, A direction to the right. Then B is going to be always, and we're going to be using these a lot, B is going to be the distance from the center to the co-vertices. Now, B is always a smaller value because that's the minor axes, okay? A is always the larger of the values, okay? Then C is going to be the distance from the center to the foci, okay? So this is going to be C. All right, so A, all right, let's write this down, is the distance. So kind of like with P, right, where we talked about distances. A is the distance from center to vertices. Okay, B is the distance from center to co-vertices. Okay, and then C is the distance from center, so notice it's always from the center, so that's the first thing we're always going to find, to the foci, which is just the word for multiple focuses, if you will. Okay, now A, B, and C should seem kind of familiar to you. Sounds a little bit like the variables we use for the Pythagorean theorem. If you need to find A, B, or C, which we will do, okay, when we go to graph this, you're going to use this. It's not A squared plus B squared equals C squared, because if you think about it, that wouldn't work here because A is always the biggest value, okay? So instead, it's going to be A squared minus B squared, because remember B is always smaller than A, is equal to C squared, okay? And that's what you can use to find any missing distance. Any missing distance, okay? And by that I mean A, B, or C. A, B, or C. All right? Then, right, another thing is always A plus between x squared and y squared, okay? So there's always going to be two squared quantities, all right? Unlike with a, so let's write plus there. Unlike with a parabola, okay? The other thing that I want you to see is if I flip back here, and I'll come back to here, okay? If you take a look here in our standard form, if we decide to here, notice there's no HK, right? But if I change this formula, right, into the standard form, where we shift it left or right or up or down, we get back to that HK form that we had with a parabola. So your center here will always be, okay, HK, just like it was your vertex, okay? So now we're not going to be talking about a vertex because we're not talking about parabolas, but we're going to be using the center, which is always HK, all right? What else? Let's see if I want to add anything here. I don't think so. Okay, so HK, H comma K, is always the center, okay? So those are the important things. Oh, okay. Then the last thing I want to talk about is the eccentricity, okay? So if there's this word, right, called eccentricity, okay, and it describes, it's a value that kind of quantifies how circular the ellipse is, okay? So like if you imagine, all right, I should say, it's calculated as C over A, right? C being the distance to the foci, A being the distance to the vertices, okay? if you take a look here, if this distance to the foci is really small, right? And then A is really big, that means you almost have a circle. So if this is close to 0, okay, with a really small foci, right, or distance C here, then it's close to a circle. Circle, okay? If the eccentricity, this value, is close to 1, right, then that means the distance to the foci is so close to this that it's almost that they're equivalent, and when you divide them, they become 1. That means then the ellipse is flatter, let's say, or stretched out, okay? And that's gonna pull it out, okay? Because your foci are gonna be closer here, okay? So that's what we're gonna be looking at as far as eccentricity, okay? Now, I'll be honest, eccentricity is not gonna be a huge thing that we talk about, but I do want you to be aware of it, okay? So, let's take a look here. Once you, I know it looks a little crazy, but once you start graphing these guys, it's not that bad, okay? So, if you take a look here, we have x squared, right, over 25 plus y squared over 9 equals 1. Oh, sorry guys. A key thing is when you write the equation of ellipse, it should always be equal to 1. Now, in our example that we're going to start with, that's not so important because it's going to be written in standard form, but when we get to some harder ones, you're going to have to rewrite it in standard form, okay? So notice, always equal to 1, okay? All right, so this guy's equal to 1, all right? So what I'm seeing right now is that this guy is going to have a major axis that is horizontal in the x direction because this value underneath the x squared is bigger than this. So that means a squared is 25. So a is 5, okay? And then because this is a smaller denominator, right, this has to be b squared, right? So b is 3, okay? Now, if it turns out that they're not the nicest numbers, okay, that's all right. You can leave it in radical form, okay? And then go ahead and just graph it, estimating it, okay? Don't worry about the transverse axes. We're not going to talk about that, okay? But I will talk about the major and minor axes, okay, and where the focus points are. These are the things I'm going to be looking for on your homework. So when I look at your homework, this is what I'm going to be checking that you find, okay? So right now, the center is 0, 0, because if you look, there's nothing added or subtracted to x and y, okay? It doesn't have a set of parentheses or a binomial squared. So this is just 0, 0, okay? My vertices is always when I use the value of a. So a is 5. So just like I would with a circle, right? I'm going to count in the x direction because it's under x, right? I'm going to spread out 5 and then 5, okay? And I'm going to label those with a V, okay? So that you can see that those are my vertices, all right? Then I'm going to give the coordinate pair. So you could just write plus or minus, right? 5, 0, all right? My co-vertices are going to be using the B value, okay? So that's 3, all right? So then 1, 2, 3, up from the center. So there's my center. And then down 3. So those are my CVs, or co-vertices, all right? And those are going to be 0, plus minus 3, okay? You can write them as separate coordinate pairs if you want, that's fine. You can now graph, make sure it's nice and like curved, okay? Kind of like a football, if you will, okay? But there's our ellipse, okay? You can see how long is the major axis. So the major axis is always the longer one using the a value. So I went 5 in this direction, 5 in that direction. It's basically always 2a, whatever a is. So that'll be 10 units. And then our minor axis is going to be 3 up, 3 down, right? Or 2b. So this will be 6, okay? So this is always 2a, and this is always 2b. Okay. Then, if I take a look here, okay, I need to find my foci. So I can see A and B in the equation, but I can't see C. So that's when I'm going to use my formula that looks, again, very similar to the Pythagorean theorem, but remember, A is always bigger. So I know A squared minus B squared equals C squared. All right, I just write it in a slightly different order than they did up above. So I know A squared is 25, I'm just stealing that denominator, minus 9 equals C squared. So therefore C, right, this becomes 16, so C is 4, all right? So that means the distance from the center to my foci is 4. So I'm gonna put some X's there, okay, because I'm not gonna actually use those points to graph it, okay? But my foci are going to be plus or minus 4, comma 0. The foci are always on the same axes as the vertices, okay? They're never on the minor axes, all right? And then last but not least, you can see this guy is kind of stretched out. So if I look at my eccentricity, okay, it's going to be C over A. So that's going to give me C is 4, right? A is 5, so this is like 0.8, which is pretty close to 1, so that means it's not really close to a circle. It's definitely pulled either, you know, and eccentricity doesn't tell you in what direction, but it's either pulled in the horizontal direction or the vertical direction. But, so this is less circular, let's just say, okay, because it's closer to 1. All right. So that's my ellipse, right? That's standard form, okay? Now, standard form should always be equal to 1, if you remember. So if you look at our next one, okay, I look at this guy and I say to myself, okay, I got an x squared, I got a y squared, and I have a plus between them. So I know this is going to be an ellipse, okay? Because eventually we'll have a hyperbola and it's going to be slightly different. So if this is an ellipse, I want this always to be equal to 1. So I'm going to look here, this is equal to 9, which is a problem. So what I'm going to do to write this in standard form, right, is I'm going to divide each one of these by 9. So then I get x squared plus y squared over 9 equals 1. And then that's my standard form, okay? Now, what is my major axis? Well, if you look, which one is A? That's what you want to always look for, okay? So which is the A squared, which is always the larger. So this is my A squared. So that means I'm going to have a major axis that's vertical. That's the vertical axis, okay? So A squared is 9, so therefore A is 3, okay? So if you remember, the major axis is always from the center, right? A distance of 3 up, right? And 3 down. So I know the major axis, the length of it will be 6 because I'll go up and down 3, right? I didn't ask you that, but just so you're aware, all right? So we always start with our center, okay? So our center here, since I don't have any H or K, is 0, 0. Okay, then here my vertices, right, we just found A. So if I start at a center of 0, right, then I'm going to go up 3, right, for my first vertice, and then down 3 for the other vertice, okay? So that's going to be 0, comma, plus or minus 3. Then my co-vertices are going to be using the B value. So that's over 1, so B squared equals 1, so B is 1. Okay, so here A is 3, so we use that to get that. B is 1, so I'm going to go to the left one and to the right one, okay? So that means I'm going to have plus or minus 1, comma 0, all right? And then my focal points, okay. So my focal points I'm going to do, again, A squared minus B squared, because A squared is always bigger, equals C squared. So A squared is 9 minus 1 equals C squared. So C squared is 8 which means C is, if I square root, right, 2 rad 2. So now, if I write my focal points, I'm going to keep it in exact form, okay? Now, remember, the foci are always on the same axes as the vertices. So that means I'm going to have to go up 2 rad 2 and down 2 rad 2. So that means I'm going to add that to the center, right, to the y value. So this becomes 0, comma, plus or minus 2 rad 2, okay? So you should see the change, right, from the center in the same coordinate as you did for the vertices. So that means this is 2 rad 2, right, is square root of 8, okay? It's just a little bit less than 9, so it's, and it doesn't have to be perfect. It's somewhere between 2 and 3, so just put it there. And then we have our little itty bitty ellipse, okay? And then our eccentricity, right, is always C over A. So C is 2 rad 2, and then A is 3. So I'll be honest with you, get my calculator for this. So what is that? 2 rad 2 divided by 3, and that is 0.94. About, right? So that's an estimate. Okay, so that's even closer to 1 than our previous example. So you can see it's even more stretched out. So this is not circular at all. Okay? In fact, it's a pretty extended, right? Like stretched out ellipse, all right? Now, last one. We have to write this, and I'm going to graph this one as well, okay? Just sketch the graph over here. But if you take a look here, you should recognize that this is an ellipse, all right? So we have an x squared, we have a y squared, and they are being added, okay? Now, if you remember when we took our quiz, if there's an x squared and a y squared and they're added, usually that would be a circle, okay? However, if I divide by 4, right, then I'm not going to be able to complete the square. These are different coefficients. So if there's a plus between x squared and y squared, and the coefficients are different, then it's an ellipse. Okay, so I'm adding to our definition up here. Right here I was saying you have to have x squared and y squared, okay? And it'd be an addition between the two. In addition to that, you also have to have different coefficients, okay? If it has the same coefficients, then it's actually a circle, okay? The different coefficients is what stretches it in either the horizontal or the vertical direction, okay? So if I take a look at this guy, I'm basically going to do what I did with the circle, okay? But you can't divide through by the leading coefficient. Here you have to factor it out. So if I group the x's together, what's this? Minus 8x, right? And then the plus 4y squared plus 4y. I'm going to move that positive 4 over, just like I did for a circle. So this is minus 4, okay? Now I can't, this is just a y squared, I wrote that wrong. This guy is good, I can complete the square for that, but this one I can't complete the square because of the 4. So I have to take the 4 out. So now this is minus 2x plus some quantity plus y squared plus 4y plus some quantity equals negative 4 plus something plus something. So I'm going to complete the square twice, just like I did with the circle, all right? So if you look at this guy, right, it's negative 2 divided by 2 squared. So that's going to be 1. But remember, there's a 4 outside here. So to balance the equation, I've got to add 4 to this side because of the 4 times 1, okay? The coefficient outside there, all right? Then this is just regular completing the square because there's no factored out leading coefficient. So this is just half of 4 squared, right? So that's going to be a 4 and another 4 over here. So now, over here, these guys will cancel, okay? And then I'll have 4, this quantity is actually x minus 1 squared plus this whole quantity, right, as a binomial squared will be y plus 2 squared equals 4, okay? So now we have this. All right, Now I have to have this equal to 1. So I'm going to divide through by 4. So then my equation, right, this will become 1, that'll become 1. So my equation now is x minus 1 squared, and you can put that over 1 if you want, plus y plus 2 squared over 4 equals 1. Okay? So now what I'm thinking to myself, well, now I got an HK, don't I? Because you can see that this has been shifted. So everybody pretty much did of the quizzes I've looked at, you guys were good with the HK in parabolas. So here my center is going to be 1 comma negative 2, okay, because I always flip the signs. Then, which one's my A? Well, oh yeah, this is bigger, so that's like my major axes. So that's telling me that's underneath my y squared, so I'm going to be stretching that vertically, okay? And therefore, so A squared equals 4, so A is 2, okay? So that means when I go to graph this guy, I'm going to just do a small little sketch here, okay? And you can sketch without graph paper if you need on your homework. Just label your coordinate pairs so I can see them. So here we're going to go 1 and then down to negative 2. That's my center, okay? And then for my vertices, I'm going to count up to 1, 2. Right, that's my vertice, and then down 2. So that will be what? 1 and negative 4, okay? So my vertices are 1, 0, and 1 comma negative 4, okay? And then my co-vertices are using the b value. So b squared equals 1, so b is 1. So I'm going to go to the right and to the left, 1 and 1, right? So that's going to change my x values by 1 from the center. So I'm going to get 0, negative 2. And then here, this one I went over, so this was at 1, 2. So that's 2 comma negative 2, okay? All right, so notice, right, I subtracted 1 and added 1 because that was my b value. And then I have my foci. Okay, so these are my co-vertices. So I can graph this. There it is. That's my major axis, so it's stretched a little bit more in that direction, okay, in the vertical direction. And then my foci, right, I'm going to have a squared minus b squared equals c squared. So that's going to be, right, a squared was 4 minus 1 equals c squared. So c will be radical 3, okay? So that's always on the major axis. So if I go from the center, I'm going to go up radical 3 and down radical 3, right? So radical 3 is a little over 1, right? So I'm going to put it about there and there. Okay, so I'm going to go 1 and a little bit. Again, it doesn't have to be perfect, but when you write the foci, you should be using the radical form, okay? So I'm changing, if you look, the y's from the center. So your foci are going to be 1, negative 2, plus or minus radical 3, right? Because we started at the negative 2, and then we went up and down. So that's what that is, okay? So that's my foci, all right? So on your homework, you're going to graph them, right? You're going to find the center, the vertices, co-vertices, and foci, all right? I don't think I give you too many where you had to complete the square, but again, it's something we've done before, so you just have to remember to factor out any leading coefficients, and there will be at least one. and also divide through by whatever the constant is here because it has to be equal to 1, okay? All right, so try the homework. We will do more of ellipses, okay, writing equations and graphing. So we have about 3 days on this, all right? Have a good one, guys. Bye.